Here's problem 3527. The laws of refraction and reflection are the same for sound as it is for light. The speed of sound in air is 340 meters per second, and in water it's 1510 meters per second. If a sound wave approaches a plain water surface at an angle of incidence of 12 degrees, what is the angle of refraction? Alright, so we're told it's the same. So let's say we're going from air to water, and we have some kind of index of refraction in air, which we don't know. And we have some kind of index of refraction in water, which we don't know. We know that our angle of incidence is 12 degrees, going from the air, let me draw it straight, into the water. So what's going to happen when we approach the water? We don't know. So here's the air, here's the water. But we do know that the laws are the same. So not only is the angle of reflection the same, Snell's law also applies. So N1 sine theta 1 should equal N2 sine theta 2. So we want to find theta 2. Theta 2 will be the inverse sine of N1 divided by N2 sine theta 1. Theta 1 is 12 degrees, as given, but we don't know what N1 and N2 are. We do know the speeds of sound, and we would say that the speed of sound in air, V1, would be equal to some pure speed of sound, which we don't know, or the index of refraction in the air. So let's call it N1. That would be the same kind of relationship that we have for the speed of light in a medium as well. And then we can say the speed of sound in water is equal to this pure speed of sound, or the index of refraction of the water. If I were to divide both of these equations, I would get that the velocity of sound in air to the velocity of sound in water is equal to, and then we can see that the pure velocity of sound cancels out here, and we have that this is equal to the index of refraction N2 over the index of refraction N1. In other words, N1 over N2 is going to equal velocity 2 over velocity 1, as if I rearrange this equation. Hence, theta 2 is going to equal the inverse sine of N1 over N2, which will be V2 over V1 sine 12 degrees. So that's the inverse sine of 1510 over 340 sine 12 degrees. What is that? .4 degrees. Let me write it again down below it. 67.4 degrees. So that is our angle of refraction. It's actually away from the normal, like this. Kind of makes sense because if we're traveling faster in the water than we are in the air, then we're kind of going from a higher index to a lower index of refraction as we would normally view it with light. So we refract away from the normal as we would do if we were going from light from a higher index to a lower index of refraction. So our angle of refraction is 67.4 degrees.